Okay, let's work on a problem in which we try to estimate an average. So we're trying to decide if we should eliminate soft drinks from our diets. And one person comes up to us and says that they have measured 30 soft drink cans and found an average of 50 milligrams of caffeine in each 12-ounce can. So that's their average from their data, or so they say. Another person says they have an average of 20 milligrams of caffeine when they measured their 30 cans. So we collect 20 cans and we gain the following caffeine amounts. So we don't have 30 cans, we have 20 cans. That's how much data we have. All right, so first, let's estimate the true average of caffeine in these 12-ounce soft drink cans. So in order to do that, we need to build a normal distribution centered at our sample's average, and the distribution is going to be spread out, right? It's going to be thin or it's going to be long and spread out according to our standard deviation. So these are two things that we need. So I need to figure out my standard deviation in my average from my sample, but good news, I have all that data right here, right? So I can calculate the average, right? The average of raw data, right? These aren't distributed. I mean, you could think about these zeros as occurring twice and use a probability distribution, or you could just count them twice in your regular average equation. You need to add up all of these caffeine amounts and divide by how many you have. Right? And once we do that, we find an average of 32.55 milligrams of caffeine. So that's where we're going to center our curve, 32.55. All right, now we can do the exact same thing to find our standard deviation using the standard deviation equation. So the standard deviation equation is I need to add all of these caffeine amounts minus the average that I just calculated. I need to square those distances, and then I divide by n minus 1, right? Because I have a sample, I'm not measuring the population. I'm not measuring all caffeine, or I'm not measuring the caffeine amounts in all 12-ounce cans. And if we do that, we get a standard deviation of about 20.333. All right, now with this information, we can build this normal distribution. Right now, I can write down that curve and I know the details of that curve. All right, now how sure do we want to be? Let's give ourselves 99% assurance. So I've got a confidence interval of 99%. I'm going to be 99% that the true average amount of caffeine is somewhere inside this interval. So that leaves me with 0.5% of probability in that tail and 0.5% of probability in that tail. So how far do I need to move in both directions? What is my margin of error? So I subtract my E, I add my E. What is E? E here is a critical value times a standard deviation, as it is with proportions as well. Now, the critical value that I use is t-scores, and the standard deviation that I use is the standard deviation of averages, which is the standard deviation of your sample divided by the square root of n, where n is the number of samples that you took, or rather the number of data points in your sample. All right, so let's get our critical value from the table later. The standard deviation from my sample, that was 20.333. I've got 20.333 in that numerator. And the square root of n, I measured 20 cans of caffeine, right? There's 20 numbers right here. So my n is 20. Now for the critical value. So I go back up to this photo or this picture, and I recognize that the critical values on my sheet give me critical values in terms of how much area is in these tails. So I could either look at I have 0.5% in one of the tails, or I have 1% in both of the tails. But either way, that critical value that we're looking for is 2.861. Right, t-values depend on how much area you want in the tail, so they depend on this picture, and then they also depend on your degrees of freedom or your sample size, right, which is degrees of freedom is one less than your sample size. So we would have degrees of freedom 19 here. All right, now that I have all the pieces for my error, I can calculate this and find that my error is about 13.0076. So pretty close to 13 there. So if that's my error, then I need to take my average and subtract my error to find my left bound of the confidence interval. And if I do that, I get 19.542. 19.542. And if I do that same thing to the right, I take my center of the curve, the average from my sample, and I add that error, and I move to the right, then I get an upper bound of 45.558. Okay, so our conclusion here is we are 99% sure the true average amount of caffeine in 12-ounce soft drinks is somewhere in between this interval. So it's somewhere greater than 19.542. Let's just say 19.5 milligrams of caffeine and 45.6. 45.6 milligrams of caffeine. All right, so that's our conclusion. Now let's see what these two guys said to us at the beginning. All right, I'm looking here. One person came up to me and said that they've measured 30 soft drinks and found an average of 50 milligrams of caffeine. Well, I'm 99% sure that the true average of caffeine amounts is somewhere between 19.5 and 45. All right, so here's 19.5. Here's 45.6. All right, I'm 99% sure that it's somewhere over here. And yet this guy is coming up and saying, well, it's actually 50. So I can probably dismiss him. All right. The second guy says that from their sample of 30 cans, that they have an average of 20 milligrams. So I go down to my confidence interval. I'm 99% sure that I'm somewhere in here, and 20 is inside that interval. So I can't really dismiss that person. They might be telling the truth. Okay, hope you found this helpful.